For example 2, continued, we have this shape, this triangle XYZ, and the vertices are x at negative 4, 7, y is at 0, 8, and z is at 2, negative 1. Well, part A asks us, what are the vertices of R as a rotation 180 degrees about O, the origin of triangle XYZ? Well, if you turn back on your paper on the first page of these notes, it said that the rule for this rotation of 180 degrees is going to be negative x, negative y. So we could graph this and we could check, but what we're going to do instead is we're just going to make opposite x's and y's. So if x is negative 4, 7, then x prime is going to be the opposite, positive 4, and negative 7. And then our y was 0, 8. So y prime, there is no opposite of 0, so it's just 0. And the opposite of positive 8 is negative 8. And then we do that for z. Z was 2, negative 1. So that becomes negative 2, positive 1. Oh, I forgot my z prime. Z prime is negative 2, 1. Pretty easy. So for what are the vertices of a rotation of 270 degrees about the origin? We can turn our page back so that we could remember our rule for 270 degrees. So turn your page over. So for the rule, it would be y, negative x. That's the rule for when we rotate 270 degrees about the origin. So our x for our triangle XYZ, remember the green highlighter, that's going to be negative 4, 7. We are going to switch the positions of x and y. So we get x prime, and we get 7. The 7 does not change, it's going to stay 7, but the negative 4 is going to become positive 4. For the y, sorry for the airplane in the background, we have 0, 8. And for y prime, we are going to switch the order. So 8 remains 8, and 0 is neither negative nor positive, so it stays 0. And we do this for z. Z was purple, 2, negative 1, and that will become z prime. We're going to switch the x and y, so the y stays negative 1, the x becomes opposite, so negative 2. All right. Example 3, using rotations. For example 4, we are asked to investigate reflections and rotations. Can you find a sequence of reflections that result in the same image as a rotation? So we are going to reflect over a line from the point T. So I'm going to draw a line of reflection that goes through point T. I'm going to do that again a little bit better. So we're starting at T, and I'm making a line of reflection. So just a straight line from T. Now what I'm going to do is I'm going to reflect X over T by drawing a perpendicular line. We did this last week. So this line goes to T, and then we need to double it in length. I'm just going to eyeball it about there. That's where x prime is going to be. Then I'm going to reflect W over the line. So I go to the line and I double how far W was away. So you might want to use a ruler for this part. And that's going to be W prime. Then I'm going to take Y and I want to make it perpendicular to this line. And then I'm going to double it. It's quite long, so you may want to measure even that they are the same length and perpendicular to line T. So that's going to be Y prime. And then I'm going to find Z prime. So Z is not quite as far away. So I want to double it. About there. So that will be Z prime. And then what I need to do is connect the dots. So I'm going to choose a different color just to make it easier to see. And that is roughly, I didn't exactly measure, but that is the same shape. And what I now need to do is draw another line of reflection so that I get the final shape, which is JKLM. And to do that, I want to find where the middle of the green figure is, the WXYZ prime. Where is the center of that from X to K, from Y prime to L? Where is it about centered? And then we just draw that line of reflection. So what we're showing here is that a rotation is the same thing as two reflections over lines of reflection that go through the center of rotation. And that is summarized for you down below in this theorem. Any rotation is a composition of reflections across two lines that intersect at the center of rotation. So we just showed that above. The angle of rotation is twice the angle formed by the lines of reflection. So if we come back up here, and we look at this angle T, the actual rotation was double that. And that is what this theorem says down here. The angle of rotation is twice the angle formed by the lines of reflection. So if we have this APB, so if we reflected line AP, so we're reflecting this line, and rotating over this angle, then it becomes BP. Well, to do the same thing using reflections, you would have to double this angle. Ooh, thunder. Wow, that was a close one. I hope you can hear it, but I'm leaving the video just so you can hear it.